You can see liquids and solids all around you. When you stand on a beach, the water stretches as far as the horizon. The solid grains of sand under your feet support you and enable you to stand up. But there is another kind of matter all around you that you can't see. You can tell it is there, however, when you see a flag flapping in the wind and feel a breeze against your face. The air around us is made up of gases such as oxygen, nitrogen, and carbon dioxide. Gases like carbon dioxide are made up of atoms and molecules, the same building blocks of matter that make up liquids and solids. A molecule of carbon dioxide consists of one carbon atom and two oxygen atoms.
Gases, like liquids, have no definite shape. But gases are unlike liquids in other ways. At a given temperature, a liquid will have the same volume no matter what kind of container it is put into. Because its volume remains the same, a liquid doesn't necessarily fill a container. If you pour 500 milliliters of liquid into a 1-liter bottle, the liquid will only fill about half the bottle. But a gas has no definite volume and will fill any container no matter what its size. The molecules that make up a gas are farther apart than those in a liquid, and they move around more freely, flying in a straight line until they collide with the container's walls or with other molecules like themselves. The force with which gas molecules hit the walls of a container is called pressure. When you blow up a balloon, you can feel and see the effects of pressure on the balloon's elastic skin. As you blow in more air, the molecules of gas in the air hit the walls of the balloon and force it to expand. The gases in the air around us exert pressure on our bodies all the time. But you don't feel this pressure because pressure inside your body pushes out with the same amount of pressure as the air pressing in. In fact, in outer space where there is very little pressure, astronauts have to wear special suits that apply more pressure to the outsides of their bodies. Without these suits, the pressure inside their bodies would force their bodies to expand, just like a balloon, and explode.
A simple experiment shows that there is pressure in the air around us. Fill a glass all the way to the top with water. Then put a note card over the glass and carefully turn it upside down. The pressure in the air has more force than the weight of the water. It pushes up on the note card and prevents the water from pouring out.
Gases behave in very regular ways that have been described by scientific laws. One law, called Boyle's law, describes what happens if a gas is forced into a smaller space or volume. When gas molecules are forced into a smaller space, the molecules hit the container's walls more frequently, and the pressure increases. The pressure of a gas is also affected by temperature. At low temperatures, gas molecules move more slowly and hit a container's walls with less force. When a gas is heated, the molecules move faster. As they collide with greater force against the container's walls, there is greater pressure. According to a law called Charles' law, if a container's walls are flexible like those of a balloon, a gas will increase in volume when it is heated. Observe what happens to a balloon stretched over a glass bottle that is put in a pot of cold water and heated. As the air inside the bottle warms up, there is greater pressure. The gas molecules in the air push into the balloon, causing it to expand.